Okay, so today we'll go over how to today we are going to do some machine learning, and we are going to apply machine learning to the stock market to predict whether a stock will go up or down based on the time series data in the OHLC. So okay, let's go over some how to use scikit-learn first. So I'm going to go over like the classic iris scikit-learn. No, it's the classic machine learning like intro for beginners, like the iris data set and predicting stuff. Okay, let's start so let's do so from scikit. Oops. Iris equals okay. So scikit-learn has some built-in data sets that like are already cleaned and like well formatted for us. So we're just gonna like import them. Like, yeah, they just. So you can see here, there's a bunch of random like data sets, and these are like really nice. These are quite simple data sets that are like really good for people to get right into machine learning. Okay, so let's import a model. Yeah, I'm gonna reference. Oops. Okay, so now we are going to get like the data. Okay, I don't know. This. What? Okay, so now we're going to split this data. Okay, so the reason we want to split the data in half is because like sometimes when you have like limited data, you want to have some of it to train your model and some of it to test on fresh data to see how your model does on data it hasn't seen before. Okay, so let's. Okay, so you get four things back. The like. Oh wait, yeah. Hold on. Okay, let's look what this X looks like. Let's look at what this X and Y look like. They are. Okay, so this is what the X looks like. And then right after, this is what Y looks like. So X is like the data, like there's some like features, like there's a bunch of like sepal length, sepal width, petal length, petal width. Like these are the four like variables. And so you take these four variables and then you output it to like one of three flowers. I should have talked about like the flower. Okay. So there are three flowers, like some three types of irises. So 0 corresponds to one type of flower, 1 corresponds to another type of flower, and 2 corresponds to another type of flower. So there's like one integer label for each flower. Like And the reason this is because sklearn does not work with strings. They only work with like numbers and integers. And the reason this is because it helps data to be more compact. Say if you have like Iris Setosa, blah, blah, blah. And then you have Iris, you only have like 3 flowers that you can have, but their names can be quite long. So instead, what you can do is you can map each of these names of the flowers to like some integer value. And then after you finish training, you can map those 0, 1, 2 back to the corresponding flower name. And what this does is it makes data a lot more compact, and it saves time in computation. That allows you to export data, like when you save it in a CSV or anything and move it around. It is a lot less memory intensive. Okay, so okay, this won't take too long. Let me try to. Okay, test size. Test size. Okay, so what we've done is we've taken this data, X and Y, and split it like half and half, where half of it's for training and half of it's for testing. Okay, let's create a model. So earlier we imported a logistic regression. That is the machine learning model we will use. And let me show you guys what logistic regression looks like. Okay, so it basically like tries to like predict like it predicts the probability of something, like so like predicts a probability of a flower being a certain type of flower, and I'm pretty sure it takes the largest probability, the flower with the large probability attached to it. So say if there's like a 95% chance it is like Virginica, Iris Virginica, and then it's like 2.5% Setosa and 2.5% can't remember the last name, but hopefully you guys get the point. So like it takes that 95%, sees it is the highest, and then it just predicts. That's what it predicts. I'm pretty sure how it works. Actually, not 100% sure, but the thing is, you don't really need to know how all this works. You can just freaking plug it in and just let the model do the work for you. Okay, so let's create a model. So model equals. Okay, let's train this thing. Model.fit x train and y train. Okay, now that we've fitted our model with some data, we can predict new values. So if you guys worked with like line and best fit, that's sort of like machine learning, because you try to fit a line between a bunch of points. I'm like talking about like middle school line and best fits. So your line of best fit is sort of like a model. And when they ask you, oh, at like x equals 4, what does your line in best fit tell you is the value at 4? And then you make a prediction based on what your line in best fit tells you. It's sort of the same thing here. So we can just make some predictions. It's like these line in best fit predictions. So model.predict. Okay. So we fed in, oops. We're supposed to feed in the training data. Okay, now we want to predict. Okay, now we want to predict how well our test data does. I mean, no, test data. So let's put in the X test data. And let's do some comparisons. Metrics. Okay, metrics is a library within sklearn that allows you to do some analysis on how well your machine learning goes. So let's do metrics dot. Okay, classification report. I'm pretty sure. Yep. Okay, so our predictions are like what we predict for the y values.
Whoa.
So let's compare our test values with the like our actual values, what with we predicted. Okay, let's do that. Okay, so see our precision is 0.95. Recall, these are a bunch of random numbers. You can just look up what they mean. Like, it's kind of confusing. There's like a bunch of these. So if you're lazy, you can just be like me and just see accuracy. See how accurate our model is. We have like 95% accuracy. That ain't bad. Okay, does anyone have any questions so far? This is just some basic machine learning. Oh, I saw someone join. Any questions? Does this all make sense? Okay, so you think, okay, is there any like inkling of like sketchiness? Oh, it's like inkling of sketchiness. Like I see it, I see why this is, but I'm like, I understand what it is, but like it's kind of like, you have like some slight doubt in your system, you know what I'm saying? Okay, so just tell me if you guys have any like inkling of like slight. Okay, it doesn't seem like anyone has that. Okay, let's get into some fun stuff. So this took us like 10 minutes, right? It probably would have taken me 5 if I remembered like all those functions and stuff, but it took us only like 5 minutes. The reason is because our data is already like nice. It's already nice because like we just took it from the sklearn like library. But in the real world, data it usually isn't like that. So this will be a little longer section. Okay. So there are a bunch of steps to creating a like model in the real world. And this is why we have 6 steps. Okay, so our objective for today is doing some time series forecasting. So what we want to do is take 5 days of OHLC. OHLC stands for open, high, low, close. And open is the price of a stock when the market opens. It's like self-explanatory. And same thing for close. It's when the stock market closed, what is the price at that point? High is the highest value of the stock price during that day. And low is the lowest value of the stock during that day. Like, yeah. So what we want to do is take 5 days of OHLC, the open, high, low, close data, past five days of OHLC data, and predict whether the stock will open up or down the next day. And what green or red means is that, like, say your stock is like $250 the night before during the closing, and the next day it's like $255 when the stock market opens. What that means is that it opened green, or like the stock went up overnight. And red means it like if it opened at like 245, for example, instead of like 255, then 245 is lower than 250, and then your stock opened lower, and therefore it's red. And so how do we do this? So I've broken down to the 6 steps. There's 8, but it's actually just 6. Okay, so we need to first get the data. So how do you make a machine learning model? You take in data, and then you feed it into your model, and then you take new data and test. Yeah, and then you just feed it in. Okay, then we have to prepare the data. So in the real world, your data is usually ugly as hell. It's usually quite ugly. Yeah, it's quite ugly. It's usually not in machine learning model format. and it's not normalized. And so that's what we need to do. We need to prepare this data so that we can feed it into our model without a problem. Next, we have to train. So we feed in our data to our model and train it. And then we have to evaluate our model. So sometimes there's bugs with machine learning. For example, like one bug is called neuron death. It's when your neurons die. Oh, whatever. Let me just explain it. Okay, so sometimes neurons can be like overexposed to like some extreme value, and then it doesn't respond to later out. Hey, I don't know what that means. Vanishing gradient. Would you like to explain?
It's the same as with like the neuron death, as you were saying.
Oh, is it like a more scientific term?
I mean, yeah, like during machine learning, you take a gradient function that you want to minimize, right?
Sure. I'm not doing any of the gradient descent.
Okay, sure. So like, okay,
Yeah.
fine. I can explain it later if somebody's interested.
Okay. Well, yeah. Vanishing gradient. Here, well, let's do some learning together on the spot with Google. Thank you. We have a machine learning expert here. Okay. Yep. It's basically the same thing as neuron death, as you said. Okay. Next, we have to use some machine learning. Okay, so we have to fix our model. Then we have to develop the trading algorithm. And then we have to we create a trading algorithm based on what our machine learning model tells us. And then we analyze the performance of our trading algorithm and see if it does anything. And then after that, we take it to the live market and then we lose money. Sorry. Oh yeah, I had a joke. Okay, you guys would probably like need a little wake up. Okay, I got a diss. I got a diss. Hey, you wish your genetic code was as clean as my Java. And my Java ain't even clean. I mean, no. Yeah. Thank you. Thank you for the reactions. Yeah, Robert. Oh, I read that as Burns for a second. Actually. Robert Burns, but it's actually okay. Thank you guys for appreciating my joke. I need to spice these things up. Okay, I did not steal this. Like some of my jokes I steal, but this joke was original. Okay, let us get the data. Okay, from Yahoo Fin. Sometimes using this autocomplete is kind of annoying. Jupyter Notebook, like like I'm typing PyCharm. Autocomplete is super nice. When I'm using Jupyter Notebook, I use like Hinterland, and it's fucking awful. I wish I could use freaking Jupyter Notebook instead of PyCharm, but you have to have the pro version, and I am not paying for a pro version. Get data. Okay. If you guys want to follow along, feel free to follow along, like on your own notebook or like in PyCharm or anything. Okay. Okay, how do we get this data? Okay, so let's do like df equal. Okay, so let's just get some data. Df equals. Let's get Apple. Let's do ticker for now. Ticker equals Apple. Ticker. Okay, get data function takes like a ticker argument and like the dates. So start date. You can just put in like some like stream data. This is super nice. Let's do all the way back to 2015. Then let's do 01, 01, 2020. So we have 5 years of data. Okay, so let's see what this data looks like. just in case you guys don't use Yahoo Fin. So it's OHLC data, open, high, low, close, adjusted close, blah, blah, blah. Volume and ticker. Okay. So what's the first thing we need to do? We need to delete some columns. If you guys, del, df, it's pretty, okay, volume, del, df, close. Whoa, that's nice. It freaking auto-completes it. Auto-completes this. What else? Just close, volume, ticker. Holy shit. Let's print it again. But hopefully you guys are all familiar with pandas, because I said to like use pandas. I said to use like pandas. Wait, to know pandas and that like info thing. The event info. Okay, we're cleaning it. We're cleaning out the useless garbage information that we do not want with OHLC. Nice. Okay, now what do we need to do? We need to normalize this data. Okay, let's create a new variable called x. X equals df dot. Let's see what this looks like now. Okay, so what it does, what PCT change, it stands for percent change, is it takes the percent change from the previous value. So from here to here, it's a minus 3.03% or 27, blah, blah. And then from here to here, it's minus 0.16. So the reason the first column becomes nan is because there's no value before this, right? It doesn't change before that. Nothing changes before this. So what do we need to do? Wait, shit. Oh wait, never mind. Okay. What? Oh, sorry. Oh, no, yeah. Okay, so what we need to do is just delete it. Let's do it before the print statement. Oh yeah, yeah. I like it when you guys produce. I delete the first row. Okay, so we have cleaned the data. We have normalized the data. So this normalizes the data. And the reason this normalizes the data is because if we did like a flat change, like, oh, excuse me. If we did like a flat change, like just like absolute value, not percentage wise, if you have like different stocks to prices, so say like Apple stock prices are usually like around $250, right? It's around like $300, right? Like, and so you need like a 10%, so a $30 change represents a 10% change. But instead you have like, but think about AMD. If it's only $30, right? If you do like absolute terms, you do $30 change on AMD, it's not the magnitude of the change isn't reflected because like $30 is only 10% for a stock like Apple, but for AMD, it's like 100%. So when you do percent change, it normalizes it across tickers and also within a stock price series. And that is why we do percent change. It is a super convenient normalization for price series. Okay. Let me just delete these print statements. Next. Oh, shoot. Here, let me move this. Oops. Wait, that's weird. I used iLook. Yeah, let's just do iLook. Pretty sure it gives me the same thing, right? That's kind of weird. It's kind of weird. Okay, whatever. If that works, what's the point of iLook? It's kind of weird. Okay, so next we need to reset the index. We don't really care about the date, so let's do x dot reset index. Draw people's place. So in place, what it does is if you do like in place, what it does is it changes this itself. If you didn't have it in place, you'd have to do something like y equals so that you don't lose what you're trying to do. Like I think it defaults to false. I'm not really sure. Doesn't really matter. Okay, next we have to drop. Oh yeah, we also want to drops the index because we don't care about the dates, right? So what it does is it like replaces this and then drops it. Okay, let's see what it looks like now. And it works. Okay, now we have to apply lambda. We need to create a new row where oh yeah, we need, since we're doing classification, we're gonna have like a true or false classification. So there are only like, yeah, the true or false classification. And so what we want to do is, so you take 5 days. So 5 days. Remember, arrays start at zero, so 5 days. And we want to know if this data will indicate whether, through our machine learning model, whether this will open up, open green, or open red. So what we want to do is turn this into a categorical feature. We want to make this a true or false, whether it will open up or open down. Okay, so what does that mean? We have to apply some sort of lambda. So, okay, so we want to make that one of the columns. So opened up. Okay, equals x dot lambda. So let's create a function for this lambda. Okay, so let's create a function, custom filter, cust filter. So when you use a lambda function, it automatically passes an argument called row. So this lambda so the pandas data frame will like just call like the function func, and it will automatically put in a row when you automatically call row. Or no, it automatically call the function and pass in the current row as an argument to your function. So that's why we can have the row here. And the reason we wanted the integer indexing is because so we can get the row value. So row.name. Okay, I'm gonna bake in a bug on purpose. And since it does pass in a row, oh yeah, let me explain. So row.name is the name of the index. And so we have integer indexing. That's why we can like modulus 6 it. Okay, so so we can access like open, high, or low, close. So let's access close because that's, and we want to see if it is greater than 0. And if it is less than or equal to 0, it will return false because like this is a Boolean statement, right? It will return true or false based on if that's true or false. Else, we want to return a NaN value. The easiest way I've found to create a NaN value is just return a float and then put in parentheses flat NaN. Okay, let's pass in our function, test filter. Okay, so we want to go this way. We want to go this way, downwards. I think axis 0 is this way, like left to right. And when we want to go up and down, it's because we want to apply it along this column, which is up and down. We need to have the axis equal to 1. This is okay. Oh, it's not lambda, it's apply. It applies to lambda. Okay, so what is the problem here? This bug here. Well, it's not like a bug that creates error. So if you guys remember what I said, there's something wrong with this opened up thing. Something wrong with that. Does anyone have the answer? Does anyone know? Okay, 5, 4. No, I'm just kidding. No, okay, doesn't seem anyone has the answer. But the reason this is wrong is because we want to take the past 5 days and predict whether the next day will open up a certain way. And so we want the true or false to be here because we want these 5 days to predict whether this will be true or false, right? And so that is our bug. So what we need to do is row name plus 1. And it just like shifts it so that it works. It sort of like shifts it up, shifts everything up. So this sort of just disappears. Sort of just disappears. It's just here to, so this goes to here. Okay. Another problem is that we want to make it an integer because, like as I said, sklearn only wants integers. Okay, so in Python, something really nice you can do is you can cast a Boolean to an int. Just by doing this. Let's see how it works. Let's see what it looks like. Oh yeah, forgot about modulus ordering. No, like operation ordering. The reason is that input row name plus 1 in parentheses. And now it is working. Okay, so what we want to do is store this. Excuse me. Okay, so what we're gonna do next, so in the end goal is we're gonna use this. This matrix, this OHLC. You know the opened up and the index. So we want to take this OHLC data and use this to predict this, whether it be 0, false, or 1, true. Okay, so we want to create this into a list of labels. So how do we do that? So let's create a new variable called labels. So let's do x open up dot drop now. And then since this returns a panda series, we actually want the underlying NumPy representation. Because, I don't know, I just do everything in NumPy with sklearn because, I don't know, I'm pretty sure NumPy works really nicely with sklearn. I've not tried using pandas with sklearn, like directly. Okay, let's print these labels. Just to make sure. Okay, does everything make sense up to now? Oh yes, I forgot to do async. As type allows you, okay. As type dot as type int like just makes everything in. Okay. And we don't want these to be decimals. I'm pretty sure it works even if they are decimals, but I just want to make, but just for the sake of like just asserting your machine learning dominance, machine learning ness. I don't know. Okay, we don't want this column anymore. It serves its purpose. Okay, you might be asking, why didn't we just like create a new? Why do we put a column there? Well, it's because when you print this X with the open up column, it allows you to debug it easier. And that's why we have it there. Okay, next. Oh yeah, we need it. Okay, so we want to take this and turn it into a like we want to turn this into as a one input for one output. Like this whole matrix is one input. However, there's a bunch of like this is giant matrix, right? Well, it's technically a data frame, but it's like a matrix, right? It's a giant matrix. So what we're gonna do next is break down this into like groups. We're gonna chunk it. Make some chunks out of this. Okay, so let's create a new function called chunks equals. We're gonna use some list comprehension. I said you had to learn list comprehension. Okay, so we want to do so from 0 to 4. It'd be 0. Okay, wait, hold on a second. So chunks. As you can see here, like 1, 0, 1, 2. How come the last element 3 here isn't in the slice? It is because when you do colon, when you do slices, it's up to the last index you want. Okay. Okay, so let's create chunks. So let's do x, a plus 5. And so this initially looks like it'll give you like 6 elements, right? Because a, like that's one element, and then the 5th, and then you keep going. So a, then you get 1, 2, 3, 4, 5. So 1 plus 5 is 6, right? However, as I mentioned earlier, it goes up only to the last element, so we'll only give this 5. Okay, so for a in range 0, so we want to start at 0. The length of the data frame we have here, and then 6. The reason we want to do it every 6, but we only get 5 columns, is because as you remember, the 6th column is for our prediction. So we do not want to use that as, I don't know, like we could use it, but like we could, but let's just not use it so that there isn't like interference with like the data and the labels. Yeah. Well, on our, like it might work, but who knows? Just to be secure. So what this will do is we'll take 5. So you take 6 rows. This will get the first 5 of those rows. And then the last row is just like sort of discarded. It's just, we don't have it. It's not in the chunks. Okay, so let's print X and then let's print chunks 0. Just to make it extra clear. Chunks. Oh yeah, oh yeah, I forgot to do values. What values does is just gets the underlying NumPy representation. Let's do chunks. It's one reason Jupyter Notebook. So let's look at this row. This is like the 6th column, right? And it is not in either of these chunks. You can see here. Oh, whatever, just believe me. The numbers are kind of weird. Okay, does anyone have any questions right now? Okay, there's actually a problem with these chunks. So like we map one chunk, like chunk 0, and we have it mapped to value labels 0. Can someone tell me the bug? Hey, machine learning expert, can you tell me the bug?
Can you go again? I was.
Oh yeah, there's a bug. If we try to like map one chunk, one of these chunks to label. Oh no, sorry. There's no pressure. If you don't know, that's fine. Does anyone have any idea? Okay, so nobody has a okay, this is kind of like tricky, but
Can you print chunks once? Can you print chunks?
I'll print one of the chunks. Here, let me make it extra obvious. Okay, now does anyone know the bug? If we try to like use one of these, like, is it like you'd have to actually know how to use sklearn though. Okay, so the bug here is when you map a array, you cannot actually map a 2-dimensional array to a single label. The reason is because sklearn decided like, no, we ain't gonna take no array to mapping one value because I don't know why. So the answer is that we have to flatten it. The reason, like, it might seem a little weird, but it's because sklearn only takes 1-dimensional things. Okay, does it make sense? They only take 1-dimensional arrays for each mapping to a label. Okay, hopefully that makes sense. Does it make sense? Yeah, let me go back to iris data. So here you can see it's just 1-dimensional, right? Yeah, okay, let's try to make an error. Okay, iris data equals oh no. So yeah, okay, you guys can just take my word for it. Okay, so you see this 1-dimensional. If it was not 1-dimensional and there's like another column, like right here, like right under this column, it'd be like a 2x4, then you'd have an error because sklearn does not take 2-dimensional values. So what you can do instead is just flatten it, and then it just makes it 1-dimensional. Okay, let's see what this chunk's looking like now. So now you can see it is indeed 1-dimensional. Okay, we have we're almost done. Okay, so a problem with this chunks thing is like sometimes there could be like extra chunk, like say, excuse me. So these chunks are like rows of like 5 OHLC time series data, right? However, like what happens if there's like random 3 boys at the end? Actually, will that be a problem? Oh. So sometimes there's a problem. Okay, no. Okay, sometimes there might be like more than one chunk than labels. So if length chunks is greater than number of labels, we need to delete the last chunk because we don't want it. Okay, chunks don't pop. -1. -1 just means last. The last one is like sort of like deformed. Pretty sure. Okay, does it make sense? Oops, I forgot to do that. So sometimes this chunks, like length of this chunks might be like 100, and labels will be like 99. So if we just pop the last one, it'll like make them full length. Okay, next we need to turn this chunks into a NumPy array. So data equals chunks. Oh shoot, I forgot to import NumPy. Import NumPy. Where should I import it? Just import it up here. Import NumPy. Dot chunks, and let's see what this looks like now. It is a two-dimensional. It is a array of bunch of one-dimensional arrays, and we are basically halfway there. Yay! Hopefully this all makes sense. If this doesn't make sense, unmute your mic and tell me. Okay. So next we need closed values and open values, so that like, because like we don't need it right now. For a model, we don't need these values. Okay. Let me make it explicit. We don't need following values for model, but we do for algo back testing. Okay. So close equals. So we've created the df earlier. Okay. To line them up. So as you remember, df, like our df earlier had like a one extra row. Like we deleted, had an extra row. So we deleted like we deleted the first row here, if you remember. So what we need to do is like, so we want to get every sixth value of the close, like the actual price. So you'd think it'd be 5, right? However, to line closes the close values with the close values with the yeah, okay. Well, let's just do df equals. Okay, remember the x had the first row of not a numbers, right? So we delete that. So let's get the fifth element, and then we want to get every fourth, every. Oh yeah, oops. So let's get the fifth value. Remember, array start at 0, so 4 is the fifth value. And then you can add in an extra column to say every other. So every other no 6 values. Because remember, 5 for data and then 1 for 5 for data and 1 for 5 for data. Sorry, 5 for data and 1 for prediction. Okay, I need some Adderall. Any of you guys dealing? Sorry. So what this does is it gets the close. It gets the close of the day before the day we are trying to predict, right? Okay, hopefully that makes sense. So you have like a 5 days, and you use that 5 days OHLC formatted data to predict the 6th day, whether it will open or close. So the close values is the 5 days, you take the 5th day, you take the close on that day, and then you get that price value, the stock price at that time, right? And then open value. So what do you do for open values? It is very similar. So here, someone type in the code. Someone figure it out. If you guys don't understand what we're trying to do right now, like our model, what kind of model we're trying to do, just tell me and I'll explain it again. Okay, can someone fill in this? Yo, someone give me it. Anyone? Can someone figure it out? It is very similar. Here's a hint. It's very similar to 4:6. Close. You're on the right track, John. No, okay. Okay, let me just draw it out. Draw on. Okay, so you have 5 days. So 1, 2, wow, handwriting is actually pretty good. And then there's OHLC. OHLC. And then OHLC. And then so here we ask a question. Opened green. Okay, so and then there's like 7, 8, 9, 10. 1, 2. Oh shoot. It started at 0, but who cares? I accidentally made it start 1. I'm a failure. 7, 8, 9, 10, 11, 12. Okay, so you have OHLC opened green. Okay, so oops. So this line before, we started at the 4th. We'll start at the 5th element, and we got the OHLC. We got the close right here. We took the close here. And then we want to know, so we want to know the price on this day. And John got it. John P. You are the winner of this trivia. I don't know. Congratulations, John. You have figured it out. Does that all make sense? Does that make sense? Does everyone understand? Hopefully everyone understands. Does it make sense? Yeah. Oh, iLoc stands for integer location indexing. Okay, so here, let me just make it explicit. Okay, so let's create a yeah, okay, X. Okay, so let's do X dot head. All right, X dot head. X dot iLoc. Okay. So you can see the values here. This is the first index, right? 0. You can see this. You guys, well, it's sort of like rotated, but you can see here, this is equal to this. This is equal to this, and so on, you know? So it's basically integer location indexing. Oh, this is part of Pandas basics. But okay, let us return all this stuff. We have successfully prepped the motherfucking data, boys. Okay, return date labels. Oh. Let's make this into a function. Why? F get ML formatted data. Ticker. Let's just delete this and just call this function. The reason we want to make this into a function is that so we can do this for like multiple tickers. Okay, so let's get that data, boys. Okay, labels, data, those values. Get ML format data, and let's pass in Apple. And we get the data we get some training data from Apple. Next, what we want to do is let's create that model. Sean, watch. Yeah, I emailed you the Zoom link over there, okay? Remember, like, so we created a model right here, model. Let's create, okay, so let's import that model. Let us get to step 4. Step 3. Okay, let's create a model from sklearn dot. Actually, forgot the model name. Okay, so we're going to get a neural network, import MLP classifier. Okay, MLP classifier is basically a neural network classification. Does that make sense? Does everyone know what that means? Okay, just type in the chat if it doesn't make sense. Just type in the chat. MLP just don't matter. It doesn't really matter what it means. It could be majorly ping pong. Just like leave it at MLP, and just think of it as a neural network classifier. Okay. Does that make sense? It's a classification that uses neural network technique. Okay, let's train this bad boy. Let's create a model equals excuse me. Let's fit our data label. Oh yeah, I was wrong there. So as you remember, we need to like fit some of the data. We need to split the data so we can use some for training the model and some for testing the models to see how it does. Okay, let's do it. What is labels? Okay, X train, X test, Y train. You should make one of these pipe. Train test split. We're almost there, boys. Labels. Okay, let's fit only the training data. Y train. We have the data. Fit basically means train, and that's it's equivalent to training the data. We have trained our model. Yay, we are doing machine learning. Oh shit, actually. Oh yeah, we don't need these right now, so. So let's just make them like underscores. Okay, let's see how this model does. Predicted. Let's get our predicted values. Model.predict. So this might look a little weird. Like we're just predicting. Might look a little weird, this sign. It's like, how does it know how to predict stuff? Well, that's because we inputted data here. So we fit the data here. So that's how it knows how to predict. Okay. Let's predict. Next test. Okay, so we've trained the model here. Now we are going to use it to predict values and take those predicted values and see how it compares. Model. Okay. We are on to step 4. Okay, let's see how this model does. Okay, so we need to import a metrics library. Classification report basically gives you a report on how good your classification is, okay? Dot metrics. Wait, no, let's just import metrics because we're going to use 2 methods for them. Okay. What? How? Okay. Let's do. Oh shit! I need to do that. Huh? Get an alpha data. Okay, let's run this. Okay, so how do we? So let's print the metrics. Metrics dot. Oh, sorry. So what we need to do is like give it the test values and compare. Wait, I actually don't know. I need to check if my order is correct. True. Yeah. Okay. Yeah. I was just making sure that like my test, like my actual and my predicted values were in the right order. Okay, and the classification report's usually pretty confusing. Let's see. So let's just see how accurate this thing is. What predict test? Oops, I put X train twice. There's bug. Fuck. Find everything, right? I have a working copy, so I'll figure out what I did wrong. What the hell? I have like exactly the same thing. Okay, let me. Okay. Let's work on this one. Fuck. Yeah, sorry, give me like 5 minutes to fix. Yeah. What? Oh, what the hell? It's literally working on. I have like exact same code. If you guys see anything different, please. Oh, I know. Oh, it's LB. Okay. I think I know the reason. It's because like my classic. We are having technical difficulties. I have no idea what. Oh. I am trying to figure out what the error is right now. Let me just copy this. I think I have to. Oh, it works on this one. I think I did this beforehand, right? I think it has to, here, let me just copy in all these. I think it has to do something with these things. Just copy all these in. Yeah, let me go over what these all mean later. One second. Oh, shit. Fuck, I literally have. I swear I have the same code. Okay. Okay. Okay, this will be learning exercise for all of us. There's data labels, data. I legit have the same fucking code down here. It's not working. It's not working up there. Does anyone see the difference? Let's please spot the difference. Yeah, okay, whatever. Difference. See the difference. Oh. Sorry, sorry, this is taking a while. I don't understand. Are you seeing this? These are like the same code, but one doesn't work. Yeah, whatever. Who cares? I'm just gonna take this. Okay, it works now. It's kind of bad. Okay. Sorry guys, I have no idea. That's super weird. I swear I cannot. Yeah, I don't know. Who knows? Oh, I think I know why. Nope, I don't know why. Shoot, how do I undo? Redo. Does anyone know the redo command? Oh, it's right here. Oh, it didn't disappear. Yeah. Sorry, I'm a little. Okay, we have our model here, and it is 50% accurate. That's kind of bad, right? Well, fuck, dude. What the heck? Why is it so bad? Yeah, let's run it again, dude. How this thing fucking. So weird. I get 60% on this. Wait, that's so weird. Why is my model so bad once? It's fucking awful. Okay. Okay, so let's go over some of these parameters. Let me just breathe first. Okay, so what is a solver? It stands for some long ass algorithm name, and it basically just converges early. Like it works with smaller data sets, and since we have relatively small data sets, we don't have like terabytes of data for our model. This is the best way to go because it converges pretty quickly. However, for larger data sets, there's probably there are better different types of solvers. Layer sizes, like if you guys know neural network, there's a bunch of like layers, hidden layers in between. So I just made them like, since there are 4 features, like the open, high, low, close, I just multiplied by 2 and put 3. I didn't really do it scientifically. 1,000 iterations, like default 200, 1,000. Found 1,000 was working nicely. It's something weird. Oh my fucking. Why? What is going on? The second function is like so much better. It doesn't make any sense. I swear, freaking, it's weird. Programming is so weird. Really, let's use the second one because I don't know. Okay, let's get into the trading algorithm. Okay, does anyone have any questions right now? Does anyone have any questions right now? Sorry. Okay, so from now I'm just gonna like copy paste the older stuff. After the class, I'm done teaching, I'm gonna go over and try to figure out what the bugs were, why there's such weird errors. But okay, let's get into it. Let's create a trading algorithm. Okay, so we need to import a logger from trades.logger import simple logger. This will allow us to log our grades. So again, logger equals simple logger. Okay, we're gonna work solely with an Apple, but I can go. Let's just go do it with Apple. It'll make it simple. We can do some for loops shenanigans to make sure it works with multiple things. So. Okay, labels. A logger basically allows you to log trades. Okay, so say I want to buy 100 shares of Apple, right? So security, I want to buy an Apple, or like Apple stock. Share price equals like 100. Like number, how many shares do I want to buy? I want to buy 100 shares. I'll buy 10 shares because I'm poor. And then that logs a trade. Does it make sense? So it basically, this logger object keeps tracks of this, and it keeps tracks of a buying of 10 shares for Apple at 100 price. And if I want to sell 100 shares, I can just put a negative there. Oops, another at shares. To short or sell, it's basically like that. Okay, that's what logger. Hey, not to brag, but I wrote this library. I'm using my own libraries in my own lessons. Sorry. Okay, so let's get some data. Get data. Okay, we're using number. Okay, now what do we want to do? We want to trade based on this data. Okay, so something we need to do is like, so I'm just gonna make a helper function. So def get. So what I'm gonna do is take data and get like some. So I'm gonna take my model and return stuff. Okay, so so let's get the value. So like a 1 or 0 equals. So we're gonna use our model to predict. However, we are going to only pass an array. However, we're gonna pass in like a 1D array. However, for some reason, scikit-learn only takes in 2D arrays, so I'm just gonna put in a list, and that'll fix our problem. Data, and then we want to get the 0th element. Well, there's only one element in there, so it's just gonna get the only element in there. Then we want to get the certainty. So there's a problem. So along with the probability, you can also get the certainty of the prediction. So in our case, we're predicting whether the open on the 6th day, every 6th day, whether it'll open up or down. It'll like be up is true or 1, and if it opens down, the stock price is lower than on the 6th day, then you get a 0, right? So we want to know, but there's probabilities attached with those too, right? So there's like a 95% chance, like there's some voodoo like machine learning magic where it also gives you probability of like a 0 or the probability 1. So if this, however, since we only have 2 points, so like if we have like a probability of 95% that it's like a 1, which means the stock price opened up, there's like a 5% chance that it opens down, right? Because 1 minus the 9.95 equals 0.05. And so predict probability, same thing here. However, so like we want to get the higher value. So max. Because like there's a 0.95 and a 0.05, and this returns the value that corresponds to the 0.95 because it's the higher value. And so like classification, what it does is it like gets like probabilities for each one, and it takes the highest probable one, highest probability that something will happen. And this is because you want to predict the value that is most likely going to happen. Like it's just like, duh. Hopefully it's duh. And so we want to get the probability. Okay. Oh. And oops. And if you know NumPy indexing, let me go down here to do some NumPy indexing. We want to get the 0th value. So NumPy.array. So you have that, right? So like I just added an extra set of square brackets, and that just gave me like a 2-dimensional array. But we just want to get that thing, the thing inside. So we're just going to do 0. And nice. So we're basically doing the same here. We're just getting rid of the outer square brackets and thing. And it's basically like this. Just look at this. Okay, next we want to return these. We need to do something fun. Okay, let's do something fun. Let's play some truth or dare. Okay. Someone give me a truth or dare question. Yeah. Okay, we spent. Yeah, we need to let's take a 5-minute break. Okay, let's do 2 truths and 1 lie. Okay. Okay, everyone gives 3 facts about themselves. No, 3 facts, and then 1 is a true, and then 1 is a lie. And then I have to guess, and then you guys can also guess mine. Okay. Okay, I gave you guys 2 truths and 1 lie. Okay, someone tell me the lie. Hey, that's cheating. You guys each guess 1, so one of you guys are going to be correct. Okay, congratulations, Robert Burris. You are correct. I do not code in Angular. I ain't no beta front-end developer. Just kidding. Yeah, okay, so Robert Burris is... Hey, Jay, we're playing 2 truths and 1 lie. And Robert Burris correctly guessed that I do not program in Angular. Okay. Okay, let's... let me take a breath. Let's get into it. Okay, let's run this damn algorithm. For I in labels, it doesn't really matter. Okay, so why labels in particular? Like, what the fuck is going on? What? Why is it doing that? What? What's going on with my ID? Cursed. Damn it. Oh, I know. Range lane. Okay, that's why it was kind of weird. Fuck. Why? Do you guys see this? Here, let me just copy paste this to another zone. What's going on? Why? Okay, let me just delete it. Death bomb. What? Oh, it's working. Yeah, fuck Jupiter. No, I'm just kidding. No. Okay, let's save this. Okay, I'll save. Refresh this motherfucker. Wait, are there Jupyter notebooks on Google Colab? I haven't used it. 11? Oh, thank you. Thank you. You are my savior. Smart man. Thank you so much. Okay, let's get back into it. Range, LAN, labels. Well, why did I choose labels? Well, it doesn't really matter because labels, if everything's right, labels should have the same length as data, should have the same length as closed vowels, should have the same length as open vowels. Because, okay. Yes, poggers. Oh yeah, okay, let's get the value and certainty. Okay, let's pass in the data. Data dot outlook. Why does it work? So fucking weird. Okay. Let me fix this. Let's see if this works. Oh, I forgot we're not working with data frames anymore. I'm just kidding. Okay, data is no. I just remembered. This is just an array. So we have like a array of one-dimensional arrays. So this gives us. So I just passed in one of the one-dimensional arrays at that index, and so we are going. And so this base. So we feed this into a model. And then what do we want to do now? We want to. We only want to make trades when we are certain about what's going to happen next, right? So if our certainty is like net, I just choose some random value. So if value, watch this. The reason this works is because if 1, if 0, so 1 and 0 is sort of like true and false. It is built on C, so I think that's where it got its sort of its inspiration. That's why it allows it, because it's built on C. Like in C, there are no such thing as booleans. You just use ones and zeros, I'm pretty sure. So if value. Okay, let's log a trade. Logger.log. Okay, so security equals, we're going to share price. We're going to use the close, we're going to buy at the close price the night before, right? Excuse me. And how many are we going to buy? Let's just buy 100. It goes 100. And then we're going to sell. We're going to sell it the next day when it opens. Because we think it's going to go up based on it, because we. And how do we sell? We do negative 100, right? Next. Else, that means okay, this, the else means that we think it's going to go lower. So what we're going to do is short it and then buy it back on the next day. Okay, let's see how this boy does. Logger.graph statistics. Let's do it. Oh shit. Okay. Okay, the reason I did so good is because we used data on, okay, we use the training data. Same time range as the training data. Okay, in the previous start date, we started at Jan 1st, 2015 and ended at Jan 1st, 2020. So let's give it some days, 1/10/2020, and end date. I was like wondering why I did so good. Okay, we are almost there, boys. Well, we basically finished. 5. Let's redo this. Yay, we made money. Yay. We are done using machine. We fucking did it, boys. Okay, does anyone have any questions? Yeah,
Hey, so ideally, could we use the high value instead of the open value while selling? Because we know
we don't know when the high value is, because like we don't know the high value until the end of the day, because like, so think is it here, stock. Just give me fucking easy ass. Let's do this. Open image into stock intraday. Honestly, yeah, this is intraday. Okay, let's open an image in new tab. Okay. So say this is one day. How do we know where the high is? Like, is this the high? Is this the high? Is this the high? Like, we never know when the high is until the. So now, so we might think it's the high over here, right? But we don't know that yet. And then it goes down and it keeps going up. Is the high over here? We don't know that yet. We do not know the high until the end of the day. So we cannot sell at the high because the high is something that we know after the day has ended. Does it make sense?
Yeah, that makes sense.
Like if we could just sell at the high, like buy at the low and then sell at the high, then we'd be millionaires instantly, right? We wish it was that easy. Yeah, no paper. I don't have to do English paper. It's kind of random. Wait, are there any other questions? Okay, let me, here. We did a lot of stuff. So let me go over what we did. Oh, someone had a message. Oh, no. Okay, let's delete all this. Okay, so let's go back to what we did. Okay, so we got the data, we prepared the data, we trained our model. I have no idea. Okay, does anyone have any questions about one of the steps or why we have one of these steps or like how we did one of these steps? Good question by John. Well, in the ideal world, what we could do, what I wish we could do is just stick in a giant ass matrix and let it do some machine learning on it. However, like machine learning, like despite the fact that everyone's gonna say it's gonna fucking take, they're gonna learn, they're gonna kill all humans because they're gonna learn how to do stuff. Machines aren't actually that smart. So we have to prepare the data because it is not in a form that is, it is not in a form, we have to put it in a form that makes sense to the machine learning model. Okay, so let me go over what we did. So we had to normalize the data. So that's part of, so here's the prepare step. We do not want the volume. We do not care. That's not OHLC. We do not want to adjust the close. Well, we probably want to adjust the close over what we have otherwise, but let's just not worry about it. We don't want the ticker because it just is apple, 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 apple over again. So that's part of preparing the data, deleting what we don't want. Then we also normalize the data using percentage change. As I was talking about earlier, a $30 change makes a lot more difference for a $30 stock than a $300 stock. So in order to reflect that, we do percent change. So that like if only like there's a $3 shift in like a $30 stock, there's a 10% change. While if there's a $30 change in a $300 stock, there's also a 10% change. So the percentage change normalizes it across different stock prices. Next, we had to clean it up a little bit. We had to delete stuff more. And then we had to chunk the data because what we wanted to do is have one matrix correspond to one value. And this is what we did here. So we took 5 rows, and 5 rows of a matrix, and then have it correspond to one of the labels. Like we do a bunch of indexing stuff so that they do correspond. So it corresponds to these labels. And so we take one of these matrices, input it in, and have it learn and have it predict what the label will be. And when it gets wrong, it fixes it. It does some more learning. And then after that, and also because like we have to flatten the matrix because it cannot be it cannot have like 2 dimensions. It has to be 1 dimension. And that is why we have to prepare the data so we can get it in a form that works for our objective.
Hey, so regarding on that, so what we did was we divided into chunks of 5, and for every 5th day we look at the previous 4 days, right?
Well,
Sorry.
chunks of 5. No, it's
Oh,
like
chunks of
basically it's sort of
6.
like chunks of 6.
Yeah,
So we take 6 rows, right? Here, let me
yeah,
just explain.
and
We take
yeah, go on.
Yeah, so we take 6 rows. We take the open of that last row and put it into the label and have a Boolean whether it was higher if it opened up or down, right?
Yep. So
And
instead
then
of
so we take the 6 and then we take the previous 5 rows and we have that as a matrix, right? And that's an input. We take that 5 rows matrix and use it to predict the 6th day open. Does that make sense?
yeah, that makes sense. So what I was thinking is instead of like dividing into 6 chunks for every day, look at the previous 5 days and do the trading. So you have more
Oh,
data. Yeah.
that is a good point. The reason I didn't do that is to like prevent overfitting.
Overfitting. So, okay. How do
It's
you
like
know
I don't
it
want
will
to have like the
overfit?
same data. What?
How do you know it will overfit necessarily if you have more data?
Well, it uses like the same like rows over and over. Well, I don't know if it will overfit. It might not overfit. Like you might be correct. Like it might not overfit. But I do this as a precaution, just in case it will overfit, right?
Okay, that's fair enough. But so during when you're doing the trading, does it trade every day or every 5 days?
Training,
Trading, like the
trading.
last part while trading
Oh,
it.
trades every 5.
Yeah, so we could
It
try.
makes a trade. It makes a trade every. It makes a trade over 2 days every 5 days. Well, no,
Yeah,
this doesn't actually trade. We're just back testing it to
I
see
mean,
if
yeah,
like.
yeah. Quote unquote trading kind of thing.
Hold on a second.
Yeah,
Okay,
sure.
thank you, Carol. Carol, is that? I don't know how you spell it. Thank you for coming to my lesson today. Have a good day. Okay, wait, could you go on?
Yeah, sure. So instead of waiting at 5 days before trading again, we can trade every day.
Yeah, we could.
That's just what I wanted to add.
Oh, I could change some stuff so it makes it so that it trades every day, but I don't know. Yeah, we can do that. That is an option, but I did not. My data is not like in that form to do trading like that.
Yeah, that makes sense.
Okay, but yeah, you are definitely correct. We can do a trade every day. Sure. Are there any other questions? All right, guys, look at these statistics. Does anyone want to question what one of these statistics mean? Right here. This. Shut. I did it in less than 2 hours. That's actually quite impressive. I thought this was going to take like 3 hours. Okay, thanks for everyone for coming. I'm just gonna wait here for like 5 minutes just in case everyone has a question that comes up. I'm gonna stop my share. Okay, so I'm just gonna stay here for like